Welcome to Speakeasy JS, the JavaScript meetup for mad science, hacking, and experiments. So I'm Ross, and I'll be your host this evening. Real quick, mad science is all about doing things for no other reason than because you can, following your curiosity and building things just because you feel like it. So today we're going to be joined by our panelist, Michael Rogers, and also our speaker, Mauve. Hi, guys.
Hello.
Yeah.
Cool. So let me just intro Mauve here, and then we can get started. So Mauve's a Node.js hacker who builds software for all kinds of different use cases. Their current focus is right now on making peer-to-peer and mesh tech and making that accessible in easier ways to developers. And Mauve's main values are user agency and privacy. And to that end, their primary project is Agrigor. I don't know if I'm saying that right. Is that how you say it? Agrigor?
Yeah, Agrigor.
Great. Yeah, it's a web browser that combines all kinds of different peer-to-peer protocols together into a single browser. So you can use, I think, IPFS, and you can use DAT or Hypercore and a few others, if I'm understanding correctly. And yeah, in addition to that, too, they're also into like cyberspace, like VR and virtual worlds and stuff, and currently building a project in that realm as well. So I think that uses WebXR and the DAT protocol, which is all really cool stuff. Cool. And then finally, I think Mauve wanted you all to know that they're very spooky.
Yeah, very important. We need more spookiness in the tech space.
Indeed. Great. So yeah. So anything you want to say before we get started, Michael? I think I'll turn it over to Mauve. Then, if not. Cool. All right. You want to get right into it? Go for it.
Awesome. Cool. So hi, friends. Thanks for coming out. So today I'm going to be talking about how I'm using standard web APIs to mix peer-to-peer protocols in Agrigor. So I'm Mauve, or Ranger Mauve, anywhere that it's relevant. I do consulting through my company, Mauve Software Inc., and I'm high-key obsessed with local-first software and the web. So what is Agrigor? Basically, it's a minimalist web browser that mixes a bunch of protocols together. And it tries to do the absolute minimum to be a browser while trying to be extendable and fun to work with. So I started working on Agrigor because there's a lot of peer-to-peer protocols out there, and each of them have their own strengths and weaknesses, and each of them also have their own APIs. It felt like there is a way to make it easier to use them together and take advantage of those strengths and weaknesses, and also to simplify how to work with them and to simplify how people can even learn how to use them. So I was also really frustrated that real browsers didn't give us access to real peer-to-peer, in that everything was using gateways, everything required the internet to work, and nothing really worked on local networks without an extra gateway somewhere or with some sort of app that you need to install alongside it. So with that said, here's kind of been my goals with Agrigor. I wanted to really simplify local first tech, so to kind of make it easy to just jump into and use. I wanted to also be open to anything peer-to-peer or distributed. So instead of focusing on a single silo, I want to kind of mix as many things together as possible and kind of have total chaos. So as well, I wanted to keep it kind of minimal and make it more customizable. So there's less things that the browser is inventing and doing for you, and leaving more room for people to do things that they want. So as well, I really wanted to partner with communities and community network projects to actually build something where they're making stuff that work for their communities and work for their use cases while also leveraging the peer-to-peer web. So how am I kind of approaching all this stuff? So at the core, Agrigor is Electron, some peer-to-peer protocols, and extensions. And the main reason I did that was to kind of reuse as much as possible from the existing Node and web ecosystem and existing paradigms that people are used to from working with the web, and kind of sprinkle some peer-to-peer on top. So we support a bunch of peer-to-peer protocols as first-class citizens of the web. So far we have IPFS and IPNS support Hypercore protocol, the older DAT protocol, Gemini, which isn't really peer-to-peer, but also I'm interested in shoving your thing in here. So if you're doing peer-to-peer stuff, open an issue, maybe we can add you to the list. So with all of these peer-to-peer protocols, they all come with their own protocol scheme. So IPFS : hyper : // and that's because they're URLs. And in my opinion, URLs are awesome, and they're one of the best parts of the web. So all of these protocols can mix together on the web thanks to hyperlinks between different web pages. So for example, you can have a page loaded from the Hypercore protocol that can load content from both IPFS and the legacy web at once. And instead of having all of those ecosystems be in their own isolated silos, we can mix them together and kind of take advantage of all of their strengths. So that is done through protocol handlers in the web. So, and namely through the web's fetch API. So fetch is what people use right now to talk to HTTP servers in regular web apps. Like they might have some nice things on top of it, but if you drill deep enough, it's probably fetch or maybe some legacy library that we're going to pretend doesn't exist. So it makes it so you can interact with these the same way you would with any other server. And it kind of simplifies the amount of things you need to learn to work with peer-to-peer protocols. Instead of needing to learn like a dozen JavaScript APIs or native APIs, you can just kind of get and put from URL. But we'll get back to that in a sec in the demo. So kind of the last piece, in addition to these protocols, is the extensions. So as I said before, we have like a thin shell, which kind of does some basic features like history and navigation and all of that. But after that, you can kind of customize anything you want using extensions. And instead of having some custom format here, it's again just regular web extensions, but now with the ability to do peer-to-peer. So in fact, the history in the browser is implemented as an extension, as well as some other browser features where you can actually take that out, rip it out, and then just add your own if you so choose. So extensions are kind of my way of giving more power to users so that they can customize their user agent. And as well, I think one of the cool things is with the peer-to-peer protocols, we can have extensions that can leverage them. So say instead of having bookmarks that I save to a cloud somewhere, I can save my bookmarks to a peer-to-peer archive and sync them with my other devices without any third party touching them. So I just wanted to give a demo about how this works. So I prayed to the demo gods, so we'll see how well this works. So right now I'm gonna, can you see the text at the top? Cool. So yeah. We're gonna make a new website called Speakeasy. And in order to make a peer-to-peer website, all I do is type in a unique URL, and there we go. So from here, I'm gonna show you all how to kind of turn this website into something that's actually useful using the JavaScript API. So as I mentioned before, we have the fetch interface. So what we're going to do is create an index.html so that we can actually have some content for our website. So as you might be used to from sending stuff to servers, you can put some text right into the Hypercore protocol. In this case, we're going to put the text "Hello World." And now if I refresh the page, we have this tiny little bit of text that nobody can see. But here, let me actually zoom in on that. There we go, make it big. So this is kind of cool. Let's maybe make it a little prettier, give it a title, maybe make the text a little bigger, make it a header. And also we're gonna use a utility I have, which just lets you style things according to the browser. So we're going to import some CSS. I'm assuming this is legible. Stop me if it's not. So Agrigore has a special theme URL. And so that can be customized from the Agrigore config files so that you can change the colors and stuff, but it can be shared by any apps that use it. So here I'm going to post a new URL, and suddenly nothing shows up because I forgot to close the title tag. See, this is why you need to treat the demo gods with respect. Otherwise, you mess up. All right, hello world. Great. So that's kind of how you can make a peer-to-peer website. But let's talk about how you can mix resources together. So if we go to the welcome screen, we have some links to useful websites. So for instance, let's check out the IPFS protocol website. So as you might be able to see in the URL bar here, we're actually loading this using the IPNS protocol. So this is IPFS's thing for resolving, for letting you to actually update your websites and also have domain names while still using the content addressable stuff underneath the hood. So I'm going to look at this and I'm like, you know what? I want to rep some IPFS logos on my website. So I'm just going to go in here, inspect their logo, and just kind of swipe the URL for myself because it's very pretty. So I'm going to copy the link and go back to my website. So what I can do now is add an image tag and just paste that IPFS URL into the website, refresh, and there we go. We just loaded things for multiple hypercores. Our main website is loaded, or from multiple protocols, sorry. So our main website loaded from hypercore protocol, and then we've embedded an IPNS URL for loading some resources. So one of the things I wanted to show here is that there's different strengths in these protocols. So IPFS is really great for deduplication of content across many websites. So this IPFS logo might be reused in a bunch of different places. However, one place where hypercore protocol can excel is just to quickly make an updatable file system. So if I want to just kind of shove a file and update it a bunch of times and maybe have a history of what my website looked like, Hyper can be useful for that. Or if I want to make something a little more private where it's not going to be all advertised on the distributed hash table, it's also useful there. So we can also go to, say, the Hypercore protocol website, and we can load their icon as well. Let me just go in here, go back to my custom websites, and we can add their logo here too. So hypercore URLs are kind of long by default, but just did an update and bam. So we have multiple things. What's cool is since we're on the web, we can do more interesting things. Like say I have a blog that I want to kind of showcase as part of this bigger website. So I can link to an entire other website using an iframe. So for example, I'm going to add a little bit of styling so this actually makes sense. I'm going to give it a width of 100 BW and a height of 100 of 50 VH. And we're just going to make an iframe embedding. I think it was the SRC attribute.
I think that's right.
Yeah. And again, we updated the HTML. And here we have my website, which, oh yeah, they have, I forgot iframes are a pain in the ass to style. But here I'm actually embedding some other peer-to-peer content within some peer-to-peer content. So what I find interesting about this is that all of these things are being loaded right now from my local cache. So if I lose internet all of a sudden, all of this stuff can still be loaded. And in fact, if I'm on the same Wi-Fi network as somebody else, if they load my hyper URL on their computer, then they'll download this stuff from IPFS and hyper and all of that directly from me over our local network. As well, I feel like interacting with this is kind of straightforward as a developer, because you're literally just shoving some files into fetch protocol. And one thing that I think is cool is that we can inspect people's websites, and we can, for example, edit them and then put the edited code back into our own hyperdrive or onto IPFS and kind of make our own thing, all without having to touch the internet or some sort of CMS. So one place where I think this will be really interesting in the future is again in the local mesh network scenario, where instead of having to rely on somebody to build an app and then deliver it to you, you can just whip something together and share it with your local community and exchange it virally through peer-to-peer networks. So let me just, I don't remember what the zoom out command was. Yeah, so that's kind of the demo. So if I may, let's just kind of go to the next steps. Oh, here, maybe technical difficulties. Oh no, why isn't it loading? There we go. Okay, so yeah, so some of the next things that I've been thinking about for Egregore is to really, as I said before, partner with projects and see if we can find a way to actually get people to use this stuff and to actually see if it's working for them. So far, there's been a few people in the community that have put some minor apps together, but I feel like there's a lot of potential for folks, and it'd be really cool to work with them. As well, some of the stuff that I showed regarding extensions, right now they're all loaded locally, but I think it'd be cool if we could distribute extensions also from the peer-to-peer network. So I can author an extension inside Egregore and then send someone a link to it, and then they can install the extension, and then we can do, you know, crazy magical stuff, all without having to go through some third-party app store or extension store or anything else. As well, I've been wanting to add more customization. For instance, one thing people have asked for is having tabs. I personally explicitly didn't implement tabs so that it can be more simple, but if people want them, then they should be able to just implement them. As well, I want to add more protocols. So another cool protocol in the ecosystem is Earthstar. As well, there's the BitTorrents protocol, which I think we could make a lot of use of, and Ethereum, because, you know, blockchains, why not? They're decentralized. As well, really kind of like see if we can get the mesh network / mixnet stuff working out of the box, where you just install the app and then it can just set up your Wi-Fi for you. And as well, we want to put together actual apps for people to fork off of and use. So I just wanted to give some shout outs to folks in the community, Kygos, MetaNotemeal, and Delta F1 and Cinnamon for helping contribute to the browser, as well Beaker Gateway and Brave as other cool peer-to-peer web browsers that we should check out. And also everyone in the DAT ecosystem, because they've really inspired me to work with this peer-to-peer stuff. If you want to get involved, you can join our Discord. You can check out the GitHub repo or open an issue if you have some ideas or concerns. Or at any point, you can just kind of bug me via DMs and you know, shoot the shit. Yeah, thanks. So questions, I guess, or
Yeah, nice. That was really, really cool. Great talk.
Thank you.
Yeah. Yeah. So I mean, the first thing I'm struck by is like how polished your demo was. Either the demo gods cooperated a lot, or I mean, there was only that one little hiccup there at the end with but that was with your slides. So good work. Congratulations. It's really impressive to build like an entire browser. So I guess my first question that I want to ask you is like, like how ready would you say the whole thing is? How many bugs are you still running into on a daily basis, and sort of also like how ambitious are you trying to be with in terms of implementing all the features that a browser would need, in the sense of bookmarks and like you were saying, tabs and all the other things that a browser needs, history. It's like pretty complicated, I think. And I think a lot of the time the Beaker people spent working on Beaker was, from my conversations with Paul, were on getting all these like standard browser features implemented. So I'm just curious about that.
Yeah, absolutely. So regarding where it is right now, I mean, I use it as a daily driver and it pretty much never crashes. So that's usually a good sign. Regarding bugs, I've actually come across a few issues, but they're actually problems with Electron. And they're problems with Electron that require touching C++ code. So it's been harder to get started and go through the whole ordeal of compiling Chrome from source. But generally, even the bugs that are there are solutions. It's just been time to implement them. And generally, they don't actually prevent me from doing stuff. Because like, as I showed before, I can work with fetch and upload stuff to IPFS and DAT, and it works. And I'm pretty happy with that. Regarding the additional features, though, I was kind of hoping to leave that to community members and kind of leave it to extensions and to shell scripts, or not scripts, like basically instead of me implementing everything in Agrigore manually, I want to be able to say like, okay, so here is the API that Agrigore gives you for like navigation and setting up frames for actually loading contents. And you can just load whatever JavaScript you want to define the URL bar and all of that, or tabs or whatever you want. And bookmarks as well. We actually do support a type of bookmark, which is a little wacky. So instead of having a bookmark bar or like folder or whatever in the browser, we create shortcuts on your desktop. So I can bookmark a page, and then that creates a shortcut on my desktop to the page. So it's like turning anything into a progressive web app. So like if I want to open up Discord, instead of installing the app, I just hit Control D or whatever, and it creates a Discord link on my desktop, and then I double click it, and that's my bookmark. If I want to organize my bookmarks, it's super complex. You make a folder on your desktop and you put your bookmarks in it. It's like totally crazy. But at the same time, if people want to add more complex bookmark workflows, they can just make an extension and add like a bookmark this page button the way they would with a regular extension. Lastly, you also mentioned protocols. So I think, unless I misheard, but like protocols that I want to support, I think I don't want to implement like everything in the world, because then it just won't boot or won't be able to, won't be maintainable. But generally, if someone is interested in decentralization and especially working offline first, I think they're a pretty good fit. Yeah, did that cover everything?
Yeah. I'm in love with this idea of like really domain specific browsers. Like there's no reason why we shouldn't have browsers that are just for developers and just for different types of developers. Like there's really no reason. And it like shouldn't be hard to play around with new protocols in the browser and see how they work and see how to interact them with a web app. Like it's really fun and cool, and like, why not? Like I'm actually on an iPad Pro most of the time, and there's not even a browser with DevTools, period. like it's ridiculous. It's like this huge untouched market or whatever. But like even with Electron and stuff, like I could see going in directions that other browsers would not be able to go in if you were just targeting developers, especially like developers that are doing new protocols. Like there's some really cool sort of inspection tools and stuff like that you could do in the network layer in Node that would show up there. Like you could do a lot of like the tooling to inspect Node processes and put them in there, which like normal browsers would never do, right?
Yeah. Also regarding like target, personally, I'm not as interested in like Node.js developers or like advanced web devs. Honestly, a win condition for me would be people that like can do a little bit of HTML and CSS, and then just like teach them the bare minimum for actually saving and loading stuff and basic JavaScript, and then just kind of go from there. Like use modern web APIs like ECMAScript modules instead of like setting up build tools and all this other complex stuff. Or like use just the built-in browser dev tools instead of like super complex IDEs. Or like if you want to make your browser dev tools be complex IDEs, just like install an extension for it. Yeah. Also, shout out to Secure Scuttlebutt folks. There's like a channel there called Micro Browseries, like microbreweries. And there's just people making all sorts of like bespoke browsers for like Gemini or like CLI based things. So you might want to check those out.
You want to hit up some of these questions in the chat here from the viewers?
Yeah, sure.
What was the hardest feature to implement?
Yeah, so honestly, it wasn't that hard. Most of it. The thing that I ran into the most trouble with was actually garbage collection of browser views. So when I did the initial implementation, like I was creating windows, but I wasn't actually uncreating them. And that meant that my memory was just like growing, and I had no idea why. And then one time I was listening to SoundCloud, and then I closed the window, and SoundCloud was still playing, and I was like, wait a minute. So I think apparently there was like an API in Electron where I had to close the web contents and then the window and the browser view, but then Electron updated and like everything changed, and I had to completely rewrite everything from scratch. But then after that, it was pretty good. Like I'd say the main thing, it's not even like what was hardest, but what was easiest in Electron that it would be hardest anywhere else is the protocol handler stuff. Because honestly, doing it in raw Chrome, it's doable, but you need to do a bunch of C++ and like really dig through the protocol, custom protocol handling code. As well, I was researching how to do it on, like, say, just with WebKit or with, you know, the built-in views in macOS or Windows or Android or iOS. And they don't have a nice thing for custom protocol handlers. They have something, but it's not as easy as being just like, here's a callback and let me return a stream, and then that's it. Yeah.
Let's do another one. So I see this question from Ryan about a little bit of a question around how people would use it. Would devs bundle this? It seems like it would just be a browser that the end user would install, but maybe I'm incorrect there. Yeah,
so I want Agrigor to work just like out of the box, where you install the deb or exe or whatever Apple uses it, I don't even know. And it just like does something out of the box. And then if you want, you can customize it and add extensions and all of that. But I also think it'd be cool if communities could build bundles with their own extensions and all of that. That makes sense. Like say there is a community where it's like we're using peer-to-peer stuff and we want to just like set people up where they install our app and then it's a peer-to-peer web with our layers on top. Like say you have like some sort of like community tracking thing that you just want out of the box by default. I want to support that use case too, but that's kind of like in addition to just like working out of the box for noobs. Because I think that's super important, because like especially a lose condition would be people needing to be a developer and knowing how to compile Agrigor before they can use it, because that is not very friendly to anyone.
Yeah, totally. Yeah, I had a question. It's kind of related to the one from I can't pronounce that name with Unicode there with the triangle in it, but
Delta 5.
What is it? Delta. Oh yeah, okay.
Delta 4.
Delta 4. Yeah. Yeah. So I was wondering, just because I'm always interested in the security angle of these things. It seems like you know I have questions around the same origin policy with like all these different protocols interacting. Is it just the same origin policy is like the protocol plus the domain plus the port. But when you're dealing with these other protocols, there might not be a domain or there might not be a port. And of course, the protocol is different. So how do you like deal with all that? And does it just work, or is it kind of hacky? Like, what's your thinking on that?
Yeah. So in the happy path before Electron broke something, the same origin policy was pretty straightforward. So like in Hypercore protocol, you have your public key that identifies your website, and so that is your origin. Or you can add a version tag if you're checking out an older version of the website. But so all of your cookies and local storage and all of that is scoped to that. In addition, I have a way to configure the response headers to provide the cross-origin request policy header. So that's basically what browsers say to like, hey, don't let anyone load me from any origin other than this, or like, hey, these particular origins can load me or not. And so in the Hypercore protocol, at least, you can have a manifest called index.json, and you can kind of do access control restrictions there. You can be like, oh, well, only such and such can write to me, but anyone can read to me. So that's kind of the happy path there. For IPFS, so in IPNS, like the roots multi-hash or domain is kind of the origin, and the same things apply, but I don't know what a manifest would look like because there wasn't any prior work that I saw. The Hypercore one is actually something Beaker implemented, and I re-implemented an Agrigor to be compatible. But for IPFS, I assume we can do something similar. And I'm guessing the folks working on IPFS Companion have the same problem. So I'll let them take the lead. Yeah.
It's also a problem that we've had to deal with in the gateway. Because the gateway has the same thing where it's like taking an address and then giving you a domain, and it doesn't want people to get at each other's stuff. So there we just we actually like did a lot of new encoding work in order to use them as subdomains. And so if you take any of those like root multi-hash addresses, you can basically treat it like a subdomain.
Yeah. I used to have a gateway for DAT as well, which also did the subdomain trick where, or the problem was you needed to base 36 or 32 encode the key instead of the default hex. And I think IPFS also had to change from the default multi-hash that starts with a cube to whatever the current one is.
It's so much more complicated. So it's normally base 58, which is like a dumb Bitcoin thing, and then those don't work because of the character set. So try to go to base 32, which will work, but then it's actually too long to be a domain, like a subdomain. Yeah. So then now it's like base 36, I think, yep. Is what they're using. It's crazy.
Yeah, that's actually what I default to in the IPFS fetch interface too. So if you upload a file, it'll give you back the base 32 URL for that file. Yeah. Wait, there was more to that. Oh yeah, the other thing, right now the cross-origin stuff is busted because I'm using Electron 11 so that we can do video streaming over custom protocols properly. Shout out to like Paul Frazee and the Beaker folks for getting that into Electron. But also it broke cores. So before it'd do a pre-flight request being like, hey, what origins support you? But now it doesn't. And that means digging around in Chromium source code again, which will have to be done.
So how do you handle HTTP headers if like I'm sending so you showed the fetch API. You can just say fetch and you can use any protocol, right? You can put in Hyper or IPFS. But if I use the option in the fetch API that lets me set HTTP headers, obviously those headers don't mean anything to Hypercore, to DAT, I'm getting all the terms mixed up. Let's just say DAT and IPFS. So what do you do there? What do you do with those headers?
Yeah, so I actually do use the headers where it makes sense. So one example of headers that are really important is the range header. So if you want to download just a portion of a file, kind of like the naive way is just like, I'm going to download the whole file and then take a slice. but HTTP provides a way to specify which portion you want. So those are headers in the request, and that's actually supported by the interface for both IPFS and Hypercore protocol. As well, there's other things like the content type that can be useful for detecting if you're like trying to post JSON or not. I'm not using that for anything fancy yet, but down the line it might make sense where you want to like encode or decode or something. I don't know. Other headers that are important. So in both Hypercore protocol and IPFS handlers, it does that index.html trick where if I fetch something in a folder and that folder has index.html, it'll just return the index.html. But what if I want to fetch a folder and actually get back the files in that content or in that folder? Or what if I want to get the files in that folder as JSON? So for that, you can specify headers. I think it was called like X no resolve or something. I just made them up, where it says, don't do the index.html thing, please just get me the files. And then if you specify the content type or the response, like the accepted content types header, I think it was called, I don't remember the details, then in the response, it'll be like, oh, you only accept JSON, then I'm going to serialize this as JSON for you. So those headers are actually really important because they're the same way as when you're talking to a web server, you might want to add some extra information for what you want from the resource. The same thing is applicable to other protocols. So for instance, as well, if I want to get the current version that the hyperdrive website is at, that's in a response header called etag, which is a standard for kind of like cache control for things. Or if I want to get the, or if I want to get like, when was this file last updated, instead of having some sort of like weird custom API, it just uses also a standard header, which I forget right now.
Is it like date or something? Yeah. Okay. That's cool though. So you basically you created this glue between the protocols and like the real peer-to-peer network, and then the like HTTP interface that it's being, or I don't know if it's I guess it is HTTP because fetch is like, yeah, it has these headers, these headers and things like that it supports. And both in the request and in the response, you're kind of either like looking at the headers or filling them in depending on what you think makes sense. And so that's almost like another API on top of the actual peer-to-peer networks that you're creating. And I guess presumably that's all hopefully documented or will be documented so that people know how to interact with it and stuff too, right? Okay.
Yeah, it's all documented in the docs folder. There are folders for the different fetch interfaces, and there's examples for all of the headers, so you can use them.
Super cool.
Like one way to think about it too is it's kind of like bringing REST without all the XML and all the other scary stuff from the HTTP world into the peer-to-peer world. And kind of all those same metaphors that web developers are used to now apply for when they want to do non-web server stuff.
Super cool. Yeah. Michael, do you have any other questions? I have so many going, so I want to give you a chance if you have.
Yeah, no, I'm good. This is really cool. I just kind of want to play around with it now. Like I just want to sit down and write like any protocol.
Yeah, I'm also just I'm surprised at how easy you said it was to put it together. I mean, I know Electron is doing a lot of like the browser kind of the work around making a browser, doing all the browser things, rendering the content, and of course that's also building off of Chromium, and that's like a whole bunch of code. So it makes sense that that part was easy, but like. Yeah, I don't know. It still seems like I don't know. Just to hook into all the different APIs that you've hooked into, and make them all work. That would be hard to get all the edge cases right on it, and make it work well. And then also having that many different peer-to-peer systems running in the same browser and having it not like crash or run out of memory, and like cleaning it up when they leave the page and all that stuff just seems like really gnarly.
Yeah. So cleaning it up when you leave the page, that isn't super good yet. But one of the things is I'm building on the shoulders of giants. So for instance, the extension support is thanks to a module called Electron Extensions. So luckily, most of the things I needed were already there, and I could just submit a few pull requests to add features that I was missing. As well with the fetch interfaces, I'd already built a fetch interface for DAT back when I worked for the DAT Foundation. And so I could basically just reuse that and add a little bit of glue to talk to the Electron protocol handler. As well, IPFS gave a micro grant to create JS IPFS fetch. And so that was going to be used for another project, but then I was like, oh, cool, I can also use that in Agrigore. And again, it was using the fetch interface, so I wasn't inventing anything new. And since the interfaces were the same between the two, the glue code was the same. As well, like keeping everything minimal also improves things, because the main thing is I want custom protocols. I want to spawn windows, and I want those windows to navigate and do like autocomplete for the history and show extension actions. And so like overall, the project is maybe, I'm going to just pull out a number and be like maybe less than 5,000 lines of codes. Or, I mean, like if you look at node modules, it's probably a lot more code. But yeah, it could be worse.
Yeah.
Never look too deeply in your node modules. Never. It's scary.
Yeah. Oh, other thing with the protocol handlers that I want to throw out. So they're actually lazy loaded. So when you boot up Agrigore, it's not doing any peer-to-peer out of the box. All it's doing is if I access a Hypercore protocol website, that's when the Hypercore protocol stuff starts up. Or if I access an IPNS or IPFS URL, that's when it starts up the JS IPFS node or tries to connect to your existing IPFS desktop companion app thing. Mm-hmm. So that kind of helps, because as we get more and more protocols and more functions, they aren't actually giving you a huge performance hit because they're not doing anything until the user uses it.
Makes sense.
But when they use it, it's slower. It's a trade-off.
I kind of wish this is how like normal like web browsers worked. Like I wish that extensions were powerful enough that you know, I could sitting here using Firefox or using Chrome or whatever, Brave, whatever browser I have installed, I could just install support for whatever protocols I want. Or, you know, and the user wouldn't even need to necessarily know they were installing support for a protocol. It could just be like, oh, I want to access this like decentralized site or this peer-to-peer site, and like I have to install this extension to do that. And I install it, and then once I've done that, I can just go to these new sites. I've sort of unlocked like a new part of the web. And then it would be great if you could get all the same hooks that you need to hook into the fetch API and to hook into iframes and all the different things that you would expect to work. And then you could get more of like a merging of the normal web and the decentralized web. And I mean, I guess you see a little bit of that with stuff like, you know, the popular like MetaMask extension for the Ethereum community, where sites that you visit on the normal web can call peer-to-peer functions that like actually end up doing stuff on the blockchain. But you can't really go to like a top level URL that's not an HTTP URL in the browser and have that like work well, which is kind of sad. So I don't know. Do you see this as like as a proof of concept to kind of push the browsers to do more of that, or do you and then like eventually maybe the Agrigore can go away and it could just be the way the web works for everybody, or do you want this to like always like, do you want this to be a browser for the long term?
Yeah, I mean, I don't see right now. I don't see where Agrigore goes away, but I would be happy if it wasn't needed. I think like we almost were there with the dweb stuff that Firefox was doing. Like we could have had custom protocol handlers. I think we also had local service discovery and TCP and UDP APIs, which is really cool. Sadly, that isn't a priority for anyone right now, but like it's possible, and I'm pretty hopeful that we will get there. Like right now, one of the things too is kind of sticking closer to the web and inventing fewer new things that are not the web. I feel will make it easier to eventually just turn these into RFCs and then just be like, okay, cool, we're integrating this into browsers, or like work off of the existing code to be like, how do we enable people to register protocol handlers? Like Protocol Labs and I think Igalia or Igalia? Ignalia? I forget the name.
I know what that is, yeah.
Yeah, so they're right now working with all of these different browser vendors to actually add APIs to make this stuff possible. So registering protocol handlers, to an extent, not the same as Electron, but kind of moving in the right direction, being able to specify the origins for these things and specify which things are secure or not. Like, this is slowly getting there. And I'm hoping that once we have like a proven use case of like, here's what it could look like once it's all in place. And once this stuff is all in place, we can just kind of like smush the two and be like, hey, how about we get IPFS on like Safari on iOS or like Android or some, like IPFS on Safari would be kind of like the wildest thing ever. Or like some indie peer-to-peer protocol like Earthstar on iOS would be like primo. Yeah. So like, hopefully it all goes away and it's in the standards, but I don't know when that'll happen. And right now I want to experiment to make that transition easier.
Makes sense. Michael, you're on mute. Okay, maybe he was talking to somebody else. Yeah, cool. Yeah, I think, I mean, let's see. Maybe I'll see if there's one more question. There's no new questions from the chat. I'll ask you one more question. Are you open to adding torrent support? I think you mentioned it earlier.
Yeah, I really want torrent support, and torrent support wouldn't be too hard. And more than torrent support, I want mutable torrent support, because I think mutable torrents are like dope. In fact, there is a web extension for Firefox using those dweb protocols called like WTP-ext. And so it actually loads torrents as websites using WebTorrent and custom protocol handlers. So I think also on the BitTorrents issue tracker on GitHub, there is an issue I opened trying to figure out a BT:// protocol, so that we can have the info hash in the origin and a path to the file or something like that. So yeah, like torrents are pretty high up there. I want people to like share their Linux ISOs and load them in Agricor from a link.
Nice. Yeah. It looks like Michael crashed out of the stream again. He always has the worst luck. Every time he's in this stream from his iPad, it like crashes him out after 5 minutes, and now his laptop also did the same to him. Poor guy. But go ahead.
Maybe it's a sign of good luck for the stream though, because like they've been going pretty well. So maybe the time he doesn't crash, that's when everything else will go wrong.
Right. Cool. Yeah. The BitTorrent stuff is pretty interesting. I tried supporting something like what you said, using the existing magnet link structure, where you just, because magnet links have been around forever and they're already kind of, they're actually whitelisted in Chrome and Firefox as a API that you can as a website you can ask to handle magnet links for people, and that's what I do on like Instant IO, for example, where you can just, it'll ask you, would you want this site to handle all of your magnet links, and you want to be able to basically like select specific files within the torrent. But we did it with like indexing in. So you sort of say like, I want the third file, and that works because everything like every file in a torrent is like in this like strict ordering, where it's just sort of a defined offset. Path probably would have been a nicer solution because then people are used to that. But I like you're right about the needing like a / so you can have an origin and all that. I hadn't thought of that. And I guess also torrent files too. That's a different thing as well, where you, at least in WebTorrent, we treat that as also a valid way to define a torrent. You sort of can have an HTTP path to a torrent, and then it will fetch it. That's
so like one of the things too is that URL could be anything. Like one thing that I was imagining is, what if you have a URL to like right now in a browser, you have a URL to a PDF, and it'll load some custom code to actually render that. What if we could have a file to WebTorrent or to a WASM module or something, and then it'll load some code to actually render that. So that could be cool. And
That's really cool.
then I could load it from my file system or from Hypercore Protocol or like whatever unhinged thing.
This is all super cool. I'm really happy to see this, and the demo is really impressive. So good work on that. And yeah, I think you crushed it. It was really well done.
Sweet. I'm glad it didn't crash.
Yeah, no, it was really good. It was really good. And I'm eager to like play around with it now. And I like the idea of leaning on each protocol where it has its strengths. So you can kind of build, you know, I can see that like this being really, it could be possible to build like a kind of complicated app with like search functionality and with like, you know, large blob files that are like, that wouldn't necessarily work well in like one protocol or another protocol. And like with all the different things at your disposal, that would make it more likely that you'd be able to kind of succeed with the tech that we have today in its current form, where some things work well and some things don't work as well. And, you know, cool. Well, I think we're almost out of time. Is there anything else you wanted to mention to people? I'll just also throw up a link here on the screen to Agrigore browser so people can check it out if they're interested in giving it a try. Is that the right link that I have there?
Yeah, that's perfect. Thank you. There's also a website, but the website sucks compared to GitHub, so it's better.
Okay. Yeah, you also don't have very good SEO. I couldn't find even the GitHub page for some reason.
Yeah. Also, like people sometimes type Agrigore with two G's because it's like aggregate. Yeah, maybe I'll need to do something about that. But I guess last thing, just like parting thoughts. Think about like a utility that might be useful for you, or that might be useful for someone that's like new to programming, like say a to-do list, and think about how you can get rid of servers and all of that and just make it work locally. Or like think about all of the different apps you have right now, where right now you're collecting everything in a central place, and think about like, what would it mean if I was just connecting to each other directly? And I feel like, see if that makes sense to you, or like see if this peer-to-peer stuff appeals, and like maybe even try just like playing around. Just make something for yourself, send it to your friend, and have them load it and just try it out.
That's great. That's the true mad science spirit. Just try it out. just go ahead and give things a shot and see if they work, and figure it out as you go. I love it.
Sweet.
Cool. All right. Well, thanks again for speaking with us, Mauve, and also it's a bummer Michael left, but thanks to Michael for being on the panel today.